This is lecture 13 in network theory. So in this lecture we are going to do problems on power and energy, right? So we have discussed this concept in the previous lectures. So across the inductor, across the resistor, what is the power, or what is the how to find the energy, right? Now, so this is the question given. So there is a practical inductor. So remember, actually the inductor is a only, it should be, if it is ideal, only 2 Henry will be there, or just inductor. But in practically, this is generally depending on the windings, so it will exhibit some resistance. That is like any practical inductor will be replaced by like this, right? So he mentioned determine energy absorbed by the inductor up to 6 seconds. And the second question is energy stored by the inductor. Next, third one, energy absorbed by the inductor up to infinity. So these three questions we need to solve. Now first, how to solve this one we'll see. Now this is the current flowing through this inductor, total inductor. That means it is having some current path or some current from 0 to 2 there is a change, and then from 2 to infinity it is fixed at 4 ampere. Now how to solve this one? Now it is containing resistor and inductor. So first we will find across resistor. So energy across resistor is equal to, the current form is given, so we know the formula of energy, ER, or what we know, W is equal to integral P dt, right? Now here I am using ER because across resistor, or we can say across 1 ohm. So ER is equal to integral, the current is given, so we can say I square into R dt, right? Now we need to find up to 6 seconds, right? That means from 0 to 2, then 2 to 6, because from 2 to 6 the current is constant, but from 0 to 2 it is varying. So that means this will be 0 to 6 first, but it will be divided by 0 to 2 one part, I square into R dt, plus 2 to 6 I square R into dt, second part. Now for the first part we need to find the equation. So whenever we know 2 points, between 2 points, what is the equation? Y minus y1 by x minus x1 is equal to y2 minus y1 by x2 minus x1. So from this formula we can find it as 2t from 0 to 2. Now that means this integration will become 0 to 2 into 2t whole square into 1 dt, plus from 2 to 6 I is constant, that is 4 ampere, simply 4 square into 1 dt, right? Now 2 square will become 4 into t square, so t square integration will become t cube by 3, and the limits are 0 to 2. Next, 4 square is 16, for integration of constant we will get t, and it is 2 to 6. Now when I substitute this 2, what we will get? 4 by 3 into 2 cube minus 0 plus 16 into 6 minus 2, right? So it is, what is this? 2 cube means 8, so it is 4 by 3 into 8 plus 16 into 4, that is 32 by 3 plus 64. So this is the energy. So 10 point, so 3 times 30, so it is 20, so 10.66 plus 64, or we can say 74.66 joules. This is up to 6 seconds only across inductor. Now we will find across the 1 ohm resistor. Now we will find the across the inductor, right? We know that across inductor EL integral P dt, but we can write as, see, we know only the current, so it will be replaced by Li into di by dt, right? So from the lecture 6, so we have discussed the inductor and capacitor. So for the inductor the power is Li into di by dt, so from 0 to 6 is the limits, right? Now we know the current expression, so this integral will be divided into two parts, that is 0 to 2 Li di by dt into dt plus 226 Li into di by dt whole dt. Now we know the I of t from 0 to 2 is 2t and I of t from 2 to 6 is 4 amperes. Now if I replace L is equal to 2 Henry, so 0 to 2 into I is 2t, differentiation of again 2t whole dt plus 2 to 6 L, that is 2 into I 4 into d by dt of 4 into dt. Now so if I integrate or differentiate 2t, we will get constant 2. So 2 into 2, 8 integration of t dt is 0 to 2 plus, see when I differentiate the constant, we will get 0, right? That means the total integration will become 0, right? So t integration of t is t square by 2 and 0 to 2 is the limits. So it will become 8 by 2, that is 4 into 4 minus 0. So 16 joules is the inductor energy absorbed by the inductor up to 16 joules, right? So this is about the determinate energy absorbed by the inductor up to 6 seconds. So 1 ohm separately we will do, that is resistance part, that is we got 74.66 joules, right? So for the inductor we got 16 joules. Next we will see that means we have to see one conclusion here. Whenever the current is constant, right, in the inductor, so the differentiation will become 0, then the energy absorbed from that point we will see that 0, right? Next one, the second question is energy stored by the inductor. So second point is energy stored by the inductor. It is 1 ohm 2 Henry. Remember, energy storing, the moment storing mechanism comes, only inductive part will store the energy, that means if I find the energy absorbed by this inductor up to 6 seconds, that is 0 to 6 Li di by dt into dt, then it is EL absorbed or energy stored, right? So we got already, it is 16 joules, so I cannot do again, so it is directly I am writing 16 joules because we already found this. Remember, it is like this. See, whenever suppose some power is there, power supply, and suppose you are having an inverter, alright, so when power is on, so this battery will keep on charging, right? And suppose in your home, suppose one bulb is there, right, which is glowing. Now this is also will give some supply, right? So this is like a inductor part and this is like a resistor path. So power, when the moment up to suppose power is there, so power will be absorbed or dissipated by the resistor R, and like in this case our bulb, right? And the inverter which will store the energy when the power supply is on, right? So that is the inductive part. So that is why I told the inductive part only store the energy. The moment power supply is off, now it will act as a source, so then it will give the energy to these bulbs, right, like this bulb or TV, whatever. So this is like a storing mechanism, right, storage mechanism. Next, the third question he mentioned energy absorbed by the inductor, energy absorbed by the inductor up to infinity. That means energy absorption, that means so the moment power supply is on, it will also dissipate and it will also dissipate, so it will energy will be absorbed by these two, inductive part as well as resistance part. So we have to find across this resistance, that is 0 to infinity, this is P dt. Similarly EL in 0 to infinity P dt. So in this case we know 0 to infinity, this is I square into R dt, and here we know integration of 0 to infinity Li di by dt into dt. So what is I square R? Suppose this I square R will be defined like this: 0 to 2, I is fixed, that is 2t whole square into 1 dt, plus 2 to infinity, and the current is fixed, that is 4 square into 1 dt. This is ER, and EL here 0 to 2, that is 2 into 2t into d by dt of 2t and dt, plus integral 2 to infinity, again 2 into 2t this is 4, right, into d by dt of 4, right. So because the current is constant. Now if you see, this is 2t square, that is 4t cube by 3, and here if you see 16 into t, and the limits are 2 to infinity. So the moment infinity comes, the total energy absorbed by the resistance will become infinity, right. And here we will get, see, this is constant, so we will get 0 here, and here we already found from 0 to 2 it will store 16 joules. But energy absorbed means resistance path will absorb and inductive path, so the total energy absorbed, E total, will be ER plus EL. So ER is infinity plus something, anything plus infinity will become infinity. That means whenever we are applying, still keep on applying the power supply, this resistance as well as the inductive part will absorb the power always, or energy always. So that's why up to infinity we will get the infinity, right. So I hope you got the how to find the energy across a practical inductor, and if it is ideal also, it will only absorb, or we can say that absorption is nothing but it will store that energy. So energy stored will be there, right. So you can do one more problem, so that is I have given in the PDF that problem sheet, then you can solve that one, second question, right. Now we'll see one more question on this power and energy across capacitor and the resistor. So this is the voltage across this capacitor and this resistor, right. So from 0 to 2 it is varying with the 6, from 0 to 2, so the variation is linear is there. Then from 2 to infinity it is constant at 6 volt. Now find the energy stored and energy absorbed by the capacitor up to 4 seconds, right. So again it is like a practical capacitor, 1 ohm and 2 farad capacitor is there. Now first we will find the energy absorbed, right, then we will see the energy stored, same concept. So first we will find the power. P is equal to, now in capacitor, what is this one, it is CV into dV by dt, right. So I hope you know from the lecture 6, right. So we have discussed the power or energy across the capacitor. Now so what is C into V dV by dt. Next, if it is this is per capacitor C. If it is a resistor, again we know V square by R, right. So this is from the lecture 5, you can see there. Now we will see how to find the energy. So energy across resistor we will find the first, then we will find the across the capacitor. So again formula, say up to 4 seconds, so 0 to 4 PR dt. Now what is PR? So 0 to 4 V square by R dt. Now again we need to find the expression for the voltage from 0 to 4. So but if you see this waveform, 0 to 2 one expression and 2 to 4 it's a constant. Now we can find from the, this is point is 2,6 and this is 0, 0. So same formula, y minus y1. So v of t minus, see, x1 y1, so 0 by t x minus x1, so t minus x1 is also 0, so y2 minus y1, 6 minus 0 by 2 minus 0 is 3. So what is v of t? It's nothing but 3t. right? So that equation we will substitute here. So 0 to 2 v square by r dt plus 2 to 4 v square by r dt. Now what is r? It's 1 ohm only. So but 0 to 2 v of t is given 3t, or we found already 3t as dt, plus same 2 to 4, v is constant here. See, from 2 to 4 it is 6 volt. So 6 square into dt by 1, here also 1. Right, now how to solve this one? So 3 square it will be 9, and a t square, if I integrate t square, it will become t cube by 3, and it is 0 to 2, plus this is 36 into constant means t, will get 2 to 4. Now if I find this one, so 9 by 3 will get 3, 2 cube 8, plus 36 into 4 minus 2 is nothing but 2. So total is 24 plus this is 72. So overall is, so 6 plus 9. So overall across ER is equal to 96 joules across the resistor only. Now we will find the across the capacitor. Again same derivations or formula we will use. E capacitor C is equal to integral 0 to 4 v CV into dV by dt whole dt, and again the integration will be, limits will be split, that is 0 to 2 C is 2 farads into v of t we will already find 3t into d by dt of 3t whole dt, plus integral 2 to 4 2 into, this is 6 fixed, that is constant, d by dt of 6 into dt. So anyway this is a constant, so we'll get 0, so the overall will become 0. But this is 2 into 3 into 3, so 3 is 9, so 18 into integration 2 into t, so this will become 3 into t. So if 3 is outside, so d by dt of t will become 1 into dt plus 0. So 18 into t square by 2, 0 to 2, we will get 18 into, so 2 square means 4 by 2 2, so it is 18 into 2 36 joules. This is across the capacitor. Now what is the energy absorbed? Energy absorbed up to 4 seconds is ER plus EC, because both will be absorb the energy. So that is ER is 96 plus 36 joules. So this is 1, so 9 is 12, so 13, 132 joules is the energy absorbed by the capacitor as well as the resistor. In the second question he mentioned, in that same question only, what is the energy stored, right? I already given the explanation, that is the storing mechanism will come over for only capacitor, right? That means energy stored is only the capacitor energy. So what is the capacitor energy? We already found, this is 36 joules. So the energy stored up to 4 seconds is 36 joules. This is the stored one. If I ask the third question, what is the energy absorbed? Energy absorbed by the capacitor, it is 1 ohm, 2 farad up to infinity. So you have to prove that the energy absorbed is equal to ER plus EL, and it will become infinity. So we already proved for the inductor, so you can prove for this in capacitor also. So that you have to do on your own, right? So this is about the energy and power in the capacitor and inductor, right? So try to do 1 or 2 problems more by using these formulas, CV dV by dt, right, for the capacitor, and Li dx